All right, chapter 7 begins. So, percent consumer applications. There's a lot of real world application, like truly, and I will, when we get to certain lessons, describe my personal real life scenarios using a number of these different things, what they're for. So, I guess from practical everything in life, banking, loans, mortgages, rents, budgeting, anything that deals with money, going to the store. I mean, that's percents. I mean, discounts, add-ons, tax. These are all different types of things that make the numbers go up or down or whatever. And you guys understand a lot of different things, but percents. So defining percents. There you go. 7-1%. And it's the only term today. We'll go through percentage here at some point. Where's that? 7.3, 7.4. I think this is about it. So a percent is basically, may not believe it, percent is a ratio. Or we can say a comparison, which is a ratio between two different quantities of a quantity to 100. So basically the part to the whole equals whatever over 100, which equals dun, 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 your percent. And I can give you just a couple quick examples before our notes here, but if we take a quiz and there's 20 questions on it, right? So that would be your whole. I'll just give you a. So we're talking about a quiz, 20 points. So that's the whole. I mean, there's 20 points on the quiz. The part would be, of those 20, how many did you get correct? So we'll say you got 18 correct out of the 20. So what did you get for a score? What's your percent? So percents are always based over 100. And then I could just, again, this is what I'm trying to figure out, because this is basically 100% here, the full. If I got it all right, all 20 questions, I would get 100%, right? So if I got 20 over 20, again, 20n equals 2,000. 2,000 divided by 20, n equals 100. You got 100 of 100%. But I could use my cross products method again. There's plenty of ways I could solve it here at this point. And if I used, again, just showing ratios and proportions here, just because this is essentially what it is, I would get n equals 90, or 90%. That's what I would have gotten on the quiz. This is always the ratio. The second part is always going to be this, of the ratio. So what they're trying to do here, they say rename each of these things as a percent. We'll do that in our notes here, but this is essentially what's going on here. And again, you should understand your proportions and ratios and all that stuff here. So why don't we flip over to notes? I don't think we'll have any more vocab until Thursday. So the first 3 lessons here are all more or less the same. What we need to be able to do is convert between 3 different forms. We need to be able to go between fractions, decimals, and percents. We have to be able to fluently throughout this chapter use all 3 of those and go between them. Fortunately, it's pretty simple to do. And we'll cover how to do all that business tomorrow. So we'll learn how to do that. And then 7.3 is going to be more or less the same thing that we're doing today. You see these fractions, decimals, real big, real small type of stuff, right? Well, today we'll just deal with more, yeah, things that'll So there we go. That's what we got coming. So back to our notes here. I'm just going to look at number 5 for a second. It says rename each ratio as a percent. And again, they're presenting us ratios here. That is fine. We see all 3 forms of ratios are represented here. I got some ratio form ones, some fraction form ones, word form over there. That doesn't matter. But if we would set up a ratio, what do I know to be true? What's my ratio that I know? 4 to 10, right. So that's my part. 4 is my part. So again, you could think like a quiz. If it was a 10-question quiz, you got 4 correct. What's your score? So then on the other side here, what do we got for a ratio? Well, again, this is forever. Every single one of these is going to end in n over 100 because you're trying to figure out your percent. So I could use my magic here, n equals 40, or you have just scored 40% on that there.
Is that failing?
What?
Is that failing in our grade system?
Yes. Yeah. 70% is the cutoff. It's D minus.
70% is a D
Right.
minus?
Yeah. Well, in the high school, it's 59%. Yeah, it's 59% is an F. Here, 69% is an F. So I don't know. We don't make that. I've asked about that.
Well, the grading
I've
is
asked
worse here
about
than
that.
in the high school.
We can chat about that some other time. Anyway, you can see, again, this ratio here and how it's always set up, this is always the same because it goes back to our definition. Percent is a ratio comparison of a quantity to 100. So, yes, that is true. Can percents go over 100%? Yes, they can. Yes, they can. Can they be really tiny? Yes, they can. Another way you could certainly have solved this, again, they show it in ratio form here. There's no law that says I can't write it in fraction form. But I could certainly have just used, if I can find the rule. How did I get from 10 to 100? Well, I just multiplied by 10, so then write equivalent ratios. Do the same thing on top, 40%. Minus multiplying by 10 there, using that rule too.
Yeah, I just like the cross products.
Notice that all of these here in today's lesson, again, they all end in powers of 10. How could I get to all of them? Right. Again, they're very, just kind of introducing the concept. So number 7 says 87 to 10. Why are you? They kind of also show up here for what it's worth on your thing here that, when you got 10, to get to 100, you just multiply both the top and the bottom by 100. But when you have 1,000, divide just the top and the bottom by 10. 1,000 divided by 10 is 100. And again, we're always trying to get your part of 100 here. It's always what's going on, what a percent represents. So, 87 over 10, what did you do? Multiply by 10 or? So then over 100, it would be 870%. And again, if you did you have 10n equals 8,700.
I think that'd be an A plus 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 plus.
Yeah, that would be pretty good. So, yes, percents can go over 100, especially when you're talking about money, and we'll cover that later on this chapter here about, big rises and things, probably heard stocks that go up 180% a year, or I don't know. We'll cover that later on this chapter. So, and this is about all we're up to this lesson here. It's just getting used to making these percents, converting between essentially fraction form to percent form. It's not hard to do. And in tomorrow's lesson, we'll learn a much more faster way to go about doing this, if you can believe it. So, but for today, number 9, I'll just give you each one to do here. How's that?
I want 9. Oh, I know I
It's
don't.
on the back side.
I want 9. 0.9
No.
over 10.
You'll all get one on the back side too, because there's just not a whole lot to do here. Alright, none of them should be,
So are you gonna draw 6? Or do we get to pick?
whatever.
Oh.
So turn those into percents. I really need the stacks, I guess, available to me. And you can tell me how you did it. You could certainly just use powers of 10 method, multiply by 10, divide by 10, whatever the case may be. You can set up the proportion and over 100 and just use cross products. Ultimately, you'll most likely use the strategies we'll learn tomorrow when we start converting between the three forms to solve this. You'll turn it into a decimal first is what you'll do.
Okay, I'm on the last one.
Faith, where's your calculator? You can use mine. If you forget one, just grab one. You want one? Oh, maybe you don't need it too. I don't know. You'll probably need it from the back side though.
Wait, so we're allowed to use our calculator for this chapter too?
Yeah, you get the calculator the rest of the year. Definitely use it if you need to.
I want
Except
11.
for-
I want 11. Can I do 11?
Can I do, I don't know. It's whatever he picks.
Can I do- I
It's
don't-
whatever- It's whatever the cup chooses.
Oh.
Whatever.
No,
Colin,
I
you can
wanna-
have
I wanna do
11.
11.
Alright, that's fine. Colin can have 11. Does anybody want 9? Faith, okay, how'd you get it?
Just multiply
And final answer was
by 9%.
9%, right. Multiplying by 10, again, powers of 10, when all you do is move the decimal one spot to the right. Right? Multiplied by 100, I would move it 2 spots to the right. Right? Right.
I
Colin,
did the
11.
cross products thing.
So n over 100, what was your equation?
So it was 9.2 over 10 equals n over 100, and then I multiplied 9.2 times 100, and then I divided it by 10, and I got 92%.
Right, and then divide by, basically just zeros cancel out. 92%, that's what we're
I was
missing.
scared about my other two, so because this one looked like it would be most likely to be at 1%, so that's why I chose to do
Right, multiply by 10, move the decimal. Eve,
Yeah.
13,
I did cross product, so 80 over 1,000,
yeah,
and then n over 100,
yep,
and I multiplied 80 by 100, which is 8,000, and I divided it by 1,000, which is 80%.
1, 2, 3, 4, right, and then divide by 1,000 on both sides, and
And then-
equals
Yeah.
8%. That's
Yay,
what you
got
come
them
up
all
with.
done.
Yep, and you could certainly just divide by 10, which just means the decimal slides one spot to the left, dividing by 10. Okay, backside, same concept here, only difference is they don't end over powers of 10. But if you're looking real closely at that bottom number, you should see that there is a multiple to get to 100 pretty easily with all these here. So your proportions will work just fine, or figuring out the rule to get to 100 will work just fine too. So I'll just do it both ways here, that way, depending what way you are setting them up. But 1 to 4, wanted as a percent here. So probably first thing I do is write it in fraction form. And if I know the rule here, I know multiply by 25, I'll get the job done. 4 times, there's my 100. What's on top? 25%. 25%. Found the rule to get to 100. If you don't know the rule, and that's going to happen, like what if we have 1/3 or something that doesn't instantly go up there? How's that going to work? So set up your proportion. Again, it's always the same thing on the right side, always, because it's always a part of 100. So 4n equals 100, divide by 4, n equals 25%.
Oh, so you can just do it normally.
Yeah, you can set it, there's the proportion method. If you did power to get to, the rule to get to 100, it's multiple. But if you use your proportion, you don't have to do both of these, it's either or. Some are using this and some are using that, so.
I prefer the cross product.
Yeah, that's fine, I just show it both, so. I mean, that's really about it. So, why don't I give you guys your 3? Number 21, 4, 2, 25, 25, 3.4 over 4, and 29. The word problem.
Okay.
No.
Your friend has a bag of 20 marbles.
How dare you do that?
7 are blue, 4 are red, 2 are green, and 3 are yellow. If the rest are white, what percent of the marbles are white?
I don't have my workbook. I don't have my workbook.
There you
There,
go.
thank you.
So 21, 25, 29.
So, do you add all the marbles that you have up and then do that under 20?
No.
I don't know.
I'd probably want to add up all the total or whatever, subtract it from 20 to figure out how many white marbles there are, right? That's probably what I want to do first.
Okay.
And then I know there's 20 total. So we could just kind of set up, something like 26 there, I bet, could get the job done. 20 whole, how many whites are there? Like that. Over 20. A part is the white marbles. I could figure out how the percent of yellow, the percent of green. I could figure them all out. I bet if I did it right, when I added up all those percents, it would total 100%.
Should I do 21?
Can I do no. Can I do 25? But I don't have 29.
There we go. 21 is for Eve.
Yay! Okay, so I did cross product.
So, okay. Like this.
Yep. And then I did 4 times 100, which is 400.
Yeah.
And then I divided 400 for 24.
Yep.
And got 16%.
16%. That's what we need. You got it. Perfect. Just like that. 25. Sam's not here. Faith.
No!
You just,
What did you do? Did you multiply
yeah.
by? And 3.4 times 25 is? 85? 85%. Right.
I'm not done
Three
yet.
point four over four equals n over 100. 4n equals 340. 340 divided by 4, 85%. Right? So 29, your friend has a bag of 20 marbles, 7 are blue, 4 are red, 2 are green, and 3 are yellow. If the rest are white, what percent of the marbles are white? So what do I got to do first, Colin?
So you said something about subtracting the number of added ones to minus 20, and that's 4.
Yeah. What?
There's 4 left.
Right, because I need that, no, well, the blue, 7, plus the red, 4, that's 11, plus 2 greens, there's 13, 3 yellows, that's 16 of the
Yeah.
marbles. Then it says the rest are white. So 16 of the marbles are not white.
So it's,
Blue, they're
so
red,
then
yeah.
is it 4 over
So
20?
now I know, how many are white? 4. 4 of the 20. 4 of the 20 are white. My question to you is then, what is that as a percent? 4 of 20.
Okay, so then you do the cross products. The
Yep.
4 times 100 is 400.
Yep,
And then that divided by 20,
yep.
and it's 20%.
20%. That's what you should come up with there. And again, I could figure out any of them. If it said the blue, just for example, blue would be this. I assure you, 35%. All right, the red is the same as white. We already did 4 over 20, right? Don't need to do it again. 2 greens. And work it out, you get 10%. And 3 yellows. 15% of them are
Do those
yellows.
all add
And then
up
if
to
I add them
100?
all up there, 55, 75, 85, 100%. As it should be, 100%. That's all the marbles, right? 20 of 20. They're all one of the 5 colors. They have to be, right? Doesn't say any of them are black. So, but yeah, I mean, I can account for all of them. All the percents are good. Questions?
No?
Okay.
Yay.